It took 40 seconds for a cup of hot chocolate to cool from 200 degrees Fahrenheit to 136 degrees Fahrenheit when an ice cube was added. True or false? At some point during the 40-second interval, the hot chocolate was cooling at a rate of 1.6 degrees Fahrenheit per second. Well, let's actually start by seeing what the average rate of change is. We already know the change in time is 40 seconds. And then we went from 136 degrees Fahrenheit, or we went from 200 degrees Fahrenheit to 136 degrees Fahrenheit. So we have to subtract the second temperature value from the first. And if we do that, we're going to have still 40 seconds in the denominator, but then on top we're going to have negative 64 degrees Fahrenheit. If we do the division, we'll end up getting negative 1 6/10 degrees Fahrenheit per second. So this is the average rate of change for this temperature value. Now what this negative means is that the temperature is going down. So if we were to, let's reread this, at some point during the 40-second interval, the hot chocolate was cooling or decreasing in its temperature value at a rate of 1 6/10 degrees Fahrenheit per second. Well, that's going to be true. And because we say cooling here, that tells us that this negative is indeed upholding. And by the mean value theorem, the cooling rate of 1 6/10 degrees Fahrenheit per second guarantees that at some point within this 40-second interval of cooling, that the hot chocolate had to be cooling at this exact rate. So this is definitely a true statement. It's also worth noting that it's not accurate to say that something is cooling at a rate of negative 1 6/10 degrees Fahrenheit. So the way this wording was in this problem, we did not need to and should not put the negative with this value because the cooling means decreasing or providing that negative value.